just a fake jump, and it reverts to the same position. As you can see, the result is again 8 in EAX register.
I guess that was another anti-debug. Ten jump za tym lupą. Teraz muszę wejść na cel.
Który jump?
Masz to jeszcze otworzone?
Aha,
Za tym lupą ten jump.
Aha, we will try now 60% of anti-debugging or anti-disassembling constructs. So in debugger it's very ugly code now because it added some jump code, some jumps in the middle of instruction. Here's the real first instruction, mov EAX, the address of that string. Again, here's jump inside the next instruction. So now we have in EAX the address. We will call the function. So it's really hard to understand, even for me. We are still not at the end of the function. We are somewhere inside. You can see many fake jumps. You can see many fake calls to return instructions. I'm trying to find the end of the loop. I'm not able. Yeah, that's it. So I will put a breakpoint here. So we are now out of that loop. This one is actually a very interesting construct because the obfuscator puts a call instruction just before ret instruction. So the call calls ret, and ret returns control again
to the call,
to itself.
to itself, to the
Yeah.
instruction.
So we are now at the end of the function.
From Python. Do you use any self-modifying code or self-modifying code?
Well, sometimes, yeah, the obfuscator sometimes use self-modification code, but it's not a part of our presentation because it's quite difficult to show how it works. So we are now at the end of the function again. And you can see the value in EAX is again 8.
That was pretty impressive.
So, the last one what I'd like to show you is multiple call of the obfuscator. We can call him 2 times. Sorry, we can call him 2 times. I will switch off anti-disassembly constructs. So here it is. We can single step through it, but it's really complicated and don't want me to describe it.
Seems like it unrolled some of it.
Sorry?
Did it do some unrolling on the code? There were many similar patterns, like push and pull.
Mm-hmm. Yeah. Well, we didn't switch on anti-disassembly construct, so it's now very easy to find the end of that loop. So I can put and breakpoint here and run it.
Nice.
So that's the end of the function, and in EAX is again just 8. So that's all. Thanks for your attention.
Ještě bych si mohl dát jednou pod masa. I think you could give some. One more.
One extra bomb.
Just to see it, just browse through the code, how it looks in reality, in a real product where it is used.
It wants me to show more. Sorry. More multiple calls. So we can try 4. Again, just rearrangement and expansion. Sorry. And I've got an error. We will start with 3 multiple calls. Or okay. So once again,
I'm sorry to be so obtuse, but I do not understand at this point how what you are doing presently is different from what you were doing a couple minutes ago. What's the qualitative difference? I understand, you know, we're pouring 10% in, then we're pouring 20% in, then we're pouring 30% in, but
You mean the multiple entry?
This is meant to be a demonstration how it looks in reality. Now, if Karel would also enable anti-disassembling tricks, you would see how it looks for crackers when they try to understand such simple things as string length.
I can't enable it because it doesn't work. I have a bug somewhere and I don't know why, where.
Okay.
So I can show it together with that construct.
It's getting close to some kilobytes already. Code.
Well, we can look how long it is now. That's the main loop. Now again you can see the result in EAX is again 8. The original size original size is 26 bytes. And if I turn it on, yeah.
It doesn't count the
Yeah.
file or something.
No, here it is. The length of the code is now 668, so it's much longer. Original size was 26. So I think that's enough. Thank you.
Oh, there's a question from Heide. Are there any programs which will help in de-obfuscating this code? Is there any programs available that will help you de-obfuscate the code, turn it back into something a bit more readable?
I'm not aware. I've heard about such tools, but I've never seen it in reality.
There are some tools, but they don't exist in the public. It's used internally by some credit groups. But they are usually made specifically for one type of protection.
Mm-hmm.
So groups like Reloaded have some tools for star falls and something else. But
Mm-hmm.
But how do
You-
you make
you-
something for
usually-
random?
well, they have some pretty talented guys, those groups. Usually they keep those tools very close to themselves, but Reloaded actually released some of the information coding written for star falls. But it wasn't a big deal of interest in it. Outside university.
Mm.
But they have tools, some of them are.
It might be possible if you know the exact algorithm of this data. In general, I believe it can be proved that it's not possible in general.
It's not possible to get back to the original code.
It's not possible 100%, but
Up to some extent.
to some extent.
Okay, so we are done with this topic.
Done.
Okay.